AP3 questions for homework. So, problem 1. Starting at 1, write out each number and if it is even. So, we're going to head back over to Tinkercad where we've been doing all our coding. We're going to create a new, that's the wrong button. Click down to circuits, create a new circuit. Drag our Arduino in so we have a little environment in which to write code. With the code block, switch over to text, continue. Alright, and we'll delete the code that we have here. And we'll paste a little comment up top with // so we can see our problem that we are working on. Alright, so starting at 1, write out each number and if it is even. So we want to start out at some number, or sorry, we want to start out with a variable, and we're going to go with I equal to 1. I is a common counter, a variable that we use for counting in programming. So we'll set it equal to 1, and we want to output if it is even. So how can we check if a number is even? So we'll think about the properties. A number is even if you can multiply by 2 to get it. So if we add a little comment, we know that 4 is even because it is equal to 2 times 2. We know 6 is even because it is equal to 3 times 2. 8 is equal to 4 times 2. And so we're noticing a pattern that everything is multiplied by 2. So we could use that property. There's another idea in programming of which you probably don't remember this from your math class many years ago, but it's of remainders. So if you do 5 divided by 2, it will equal 2 with a remainder of 1. 4 divided by 2 would be 2 with a remainder of 0. And the way you go from this right side back over to the left side is you multiply the whole number and then you add whatever's left. So 2 times 2 plus 1 is 5. 2 times 2 plus 0 is 4. If we went up to like 9 divided by 2, that would be 4 with a remainder of 1. And if we kept going, you'll notice that every even number has 0 remainder, whereas every odd number has a remainder of 1. And that kind of gives us, I don't remember if you noted before, but 1 can kind of be, 1 and 0 can be converted to booleans, where 1 is true and 0 is false. And we can say if there is a remainder, then it's odd. If there is not a remainder, then it's even. And we can use these properties to tell if something is even or not. So how might one do this? So if we go over to the Arduino documentation, which I had mentioned, I always forget how to get there. Resources, reference. So here's the documentation. So if you come down and we look at math, and I know these are kind of, I know what these all stand for. So apps is for absolute value. Actually, I don't know what all these are for. Max thing is for the max value, min for the min value. Okay, so it's not in math. What other sections? We have random numbers, we have trigonometry. None of these look like it. Keep going. What else we got? Structure. We have comparison, we have arithmetic operators. All right. So it looks like, as I mentioned, remainder and division, I think, are the two things we'll want. So, yeah, so this is exactly what we want. So, remainder operation calculates the remainder when one integer is divided by the other. It is useful for keeping a variable within a particular range. Blah, blah, blah. The percent symbol is used to carry out remainder operations. So, 7 remainder by 5 will give you 2. So we can use that. So if we come back over and we'll do int remainder equals I divided by 2. And if the remainder is equal to 0, we will want to print out. So first we need to print out the number, and then we need to print out if it's even. So first let's serial.print without the ln the value of I. And then we will serial.print even. Else we'll want to serial.print odd. And this will want an ln. This will want an ln. Actually, I'll say why. We'll look at that in a second. Okay, so let's see what we got. Nothing is happening. Interesting. Okay, so I'm kind of surprised that it didn't yell at me, but I do have to init. I think this is the issue. To do my serial.begin. Okay. So that kind of looks weird. It looks like I forgot to increment I. So we'll stop your simulation, we'll go I++. Also, we noticed that everything was scrolling horizontally. And that is because we forgot to add in ln, which stands for printing a new line. So we'll want to print a new line. Let's go with that. Let's see what that gives us. Better. We don't want it all connected, though. So what we can do is we can come in here and add a space here and a space here. And also let's add a delay so we can actually read what's happening. So 100 milliseconds or 1/10 of a second. And when we start that, that's still very fast. Let's go 500. Clear that out. And there we go. And so that's how you tell if something is even or odd. And I'm going to throw y'all with a different solution real quick. Actually, we'll do like this. Problem 1, solution 1. And we'll post this into the thread on Slack. If you're not in Slack, check out the link below in the About section to register and get yourself on Slack. Okay. So there's actually another way we can solve. I mean, there are probably several ways we can solve this because every problem can be solved in many different ways. But we can do this without division. And so, quick little tangent. Division is actually quite strenuous on a computer. I don't even know how much information I want to give beyond that because it's a whole can of worms there. But division, not good. And so if you can get by with it, without it, addition is always kind of the ideal way to do things because you can actually do a bit of a mind bender for you. You can do division with addition. It's very confusing, very chaotic. I don't even really understand it, but yeah, so it just adds more steps. So if you can solve problems with addition instead of division, all the power to you. So what we're actually going to do is we're going to have a little counter. And every time the counter equals 1, we'll print out even, and then we'll reset it. So we don't need remainder anymore. We'll change this to counter. All right, so if we start at 1, then the counter equals 1, then we'll print even. So now we'll just do if counter equals 1, counter equals 0. So we'll reset it. Otherwise, counter plus plus. We'll increase it by 1. I think it should be everything we need. Let's see what happens. Cool. And there you go. Another way to solve it, but with addition. Let's clean this up a little bit. I'll call this solution 2. I always thought this kind of stuff was pretty nifty. So anyway. All right. So that is problem number 1. Problem 2. Let's multi-line this and then just kind of add arbitrary enters in here until we can read it all. Okay. So problem 2. And we'll call this solution 1. Create a script to receive messages and respond. If the message is hello, respond with hello to you too. If the message is goodbye, respond until next time, and otherwise respond, I don't understand, sorry. So, if you'd noticed before, we had this little text box and we can send to the Arduino. But we type in things, can't send it, well, I guess because we're not starting the simulation. Also, there's some errors in our code because there's no code in there. Let's just add those in real quick. Okay. So we can start our simulation. And it's running, so the Arduino is running. We can send stuff, it just doesn't do anything with it. So, go over to Google, send text to Arduino. Cool. All right, so I don't know if this feels good. Let's see. Well, we know we want to do it via serial because that's how we've been communicating. So let's take a look at that. Arduino tutorial, serial inputs. This looks good. All right. I always skip all the text, but good to read it if that's helpful. All right, so it looks like serial.read. If serial.available, so I guess if we're using serial, we'll get the input, and then we'll print the output, or print what we get. So it looks like we typed something, and then it outputs like that. But what if we want to put it all in together? All right, so here's a little bit that I'll fill you guys in on. /n means new line. So when you hit the enter key on your keyboard, it adds a /n. And so when you type in here and hit enter to send the message, it'll be a /n. So let's see if we can take this sketch, kind of learn from it, and maybe we can build upon it. Because that's always what you want to do in programming, is get sketches, learn off the shoulders of others. You don't always want to do everything completely from scratch. Did they disable paste from their website? Or can I just not paste in here? Can you not paste in here? What is happening? Oh, my keyboard's just not working. Weird. Nope, I can... Wait, my keyboard just doesn't work specifically. Oh, right, because I'm running a simulation. Duh. There we go. Okay, let's try this again. All right. Let's see what happens. So it looks like... Ah. Thanks, Joshua. I hope you appreciated the forehead slap I threw in there while I was struggling to figure out what was going on. All right, so we have a setup. We set up serial, we wait 2 seconds, then we print out what is your name. And then if a message is sent, we will print it out. So we'll say, Bob, My name's not Bob, my name is Travis the Maker. I hit enter, send it. Nice to meet you, Travis the Maker. So surprisingly, we've actually found ourselves almost all the way there. So how can we rework this sketch to solve this problem? If the message is hello, so this feels like an if-else kind of case, but we have three different things. If the message is hello, do one thing. Else, if the message is hello, or sorry, if the message is goodbye, do another thing. Otherwise, some standard kind of case. So we don't need this. We don't need the delay. We don't want to call this my name. Let's call it something more easy to understand. So we'll say it's a message. And we'll want to do some conditional stuff off of this message. So if the message equals, what did we write? Hello with a capital H, we will respond Now it's always good to keep an eye on the requirements for your problem. So serial.println, we'll want to send back hello to you too. Cool. So now we need an else if. An else if just means we want another if condition to look at. So in this case, we want to look at if the message, I believe, was goodbye. We'll want to serial out print. Until next time. Cool. And then we want our base case. Otherwise, don't got any idea what's going on because we're just a simple little robot. And we're going to print, I don't understand. Sorry. Throw that in there. Put that down. And that should be it. Let's see what happens. All right, we are connected. Let's send hello. Hello to you too. What about goodbye? Okay, that's a bug. Why does hello to you too? Oh, I've done a terrible, terrible mistake. Okay. This is kind of embarrassing, but we're learning together. We're learning together. Gosh, I really can't believe I've done this. Okay, so the thing I did was, and I think a thing that catches beginners often is the equal sign. So there are arithmetic operators and there are comparison operators. So the equal sign versus the double equal sign. So let's go back to here and we'll take a quick tangent on my bug before I solve it. Stop simulation. So we're in a little commented area. So say message, we'll say message is equal to hello. Versus this. So basically what is happening here is this one is the assignment, which is saying take hello, the string hello, and assign it to message. The double equals, on the other hand, says take whatever message is, the variable that we've declared somewhere else, and compare it to hello, and give us back a Boolean. So the result of this will be that message is equal to the string hello. Whereas the output of this will be a Boolean of true if message equals hello. And this is what I did to myself, is I actually assigned hello to message and I wanted to compare them with the double equals. So I'll add double equal in, starter simulation. Try that again. Get hello to you too, say goodbye. Get until next time, and then if we type in anything else, I don't understand, sorry. So this brings up another fun point. What is this? What is this mess? Arduino is pretty basic. The amount of oomph, the amount of energy, the amount of memory, the amount of storage, all that good stuff that the Arduino has is like, if we're comparing cars, an Arduino, I don't want to, it's a bad comparison. Basically, the Arduino is good at simple things. If you wanted to play the brand new top of the line video game that just came out, Arduino just wouldn't make sense for that. Arduino is very simple. It doesn't have a lot of space. It does simple things. It cuts corners so that it can be cheap. It has its use cases. You're never going to play like super complicated video games on an Arduino because that's just not what it's about. And so one of those things is that you don't get the full character set. I wonder if I'm making this up. I wonder if I actually put a slash in here and I'm just completely full of myself. Let's see what happens. Nope, still does that. Let's see. All right, so before I keep talking, let's look this up. Serial.print doesn't output apostrophe. Here we go. Love Stack Exchange. You get answers to all your questions. Okay, he doesn't even answer the issue. This is about Python. Did I not even read this? What is happening? This isn't even about Python. Very confusing. Okay, here we go. This looks better. In C/C++ string, you can escape a special character by proceeding with a backslash. Wait, I did that. I'm so confused. Okay, so I think this is a fish shaker from Mac computers. No, I definitely did this on Windows. Is it from here? I'm so confused. Okay, wait. Let's see something. Okay. This is a fun another problem that y'all will experience sometimes. So if you notice, I copied the problem from Google Slides and I pasted it in here. Look at how it's shaped. It's slightly downwardly slanted. Let's see, we just zoom in way far. There's no way I'm going to be able to even look at that. Oh, yeah, here we go. No, just kidding. This is as far as we can go in. Look at the shape of that. So that's off my clipboard. I copy and pasted that. This is my keyboard hitting the single quote string. They're different. This little guy seems to just haunt every developer's life. So in some languages, so this is a string right here. In some languages, you can do strings with single quotes or with double quotes. C++ is not like that. But that's fine. But if you throw in the backticks, you'll notice the color doesn't change. Like, I don't know where these come from, but they cause issues all the time. So basically, that's what happened. And I don't actually have the full answer of why that happened, but I don't even think I need to escape it, actually. Yeah, I don't have to escape it. Fun. So so what that slash meant there is if I wanted to add double quotes into my bits like this, like I wanted to do like understand, you'll notice that kind of the color starts to change and it looks like we have a string here and a string here, and this, who knows what happens. So if we run this, we're going to get an error. And the reason it's happening is because we actually need to escape these to be able to use them in our code. So if we run it now, and send it, and then we can actually use those. And escaping is the process of using special characters that would otherwise have meaning in code and put them into things like strings. Cool. All right, so that is solution number 2. All right, and last problem. All right. So, I'm not going to do multiple solutions for this one. Fizzbuzz. So starting at 1, output fizz if the number is divisible by 3, output buzz if it is divisible by 5, and output fizzbuzz if it is divisible by 3 and 5. Otherwise, output the number. So we can take kind of our learnings from problem 1 and repeat them with remainders. So we'll start with our int I equals 0 because we're going from, we're starting at 1. Okay, can't read the instructions. So we'll do our, we'll do remainders. If I divided by 3 equals 0, serial.println fizz. Else if I is divisible by 5 equals 0, we will output buzz. Else if I divisible by 3 equals 0 and I by 5 is equal to 0, and lastly, else print I. And then we'll want to increment I, and that should be it. All right, so starting at 1, output fizz if it is divisible by 3, yep. Output buzz if it is divisible by 5, output fizzbuzz if it is divisible by 3 and 5. Otherwise, output the number. So we'll add a little delay, start this up, and you can see this is going well. So we should expect 15 to be fizzbuzz, but it's actually fizz. Interesting, interesting. Okay. So this is a fun little gotcha. So we notice if I is divisible by 3, but it also happens down here. But in an if, else, else, whichever condition evaluates to true first is going to be what gets outputted, and then the other ones will not get considered. So for this to work, we actually need to move this chunk of code up to the beginning. So we'll take this and delete this. Take this else if and tack it on here. And now we will check first if it's divisible by 3 and 5, and we'll output fizzbuzz. And then we'll keep going, and that should give us, forgot the curly that we need there. All right, what's the serial amount I got? 9 is fizz, 10 is buzz, fizzbuzz. 18 is fizz, which makes sense. 24 is fizz, which makes sense. 25 is buzz, which also makes sense. Cool. So there is our fizzbuzz. Did I write problem 3? I did. Cool. All right. Are there any questions? Sorry, I blew through that pretty quickly, but if there are any questions, please feel free to throw them in chat real quick. I'll be able to respond to anything there as needed. Otherwise, if you need time to digest them, but I wanted to get them out before end of day. All right. I'll stick around chat as I finish doing my things, getting the video recordings off to YouTube and things like that. If you have any questions, feel free to throw them into Slack, and I'd be glad to answer them. Otherwise, I will see y'all tomorrow. Peace.